the Big Bang, the Big Crunch, the Big Freeze, and the Big Bounce. These are some of the commonly accepted theories surrounding the creation and the future of the universe. They all have one thing in common, and it's not the word big. The one thing that ties them all together is that they are all just theories. The cold hard facts are that we haven't yet proven any of them to be true. Join us as we look into what we currently know about the universe before delving into some unsettling alternative theories that will challenge conventional thinking and have us wondering if everything we know about the universe was wrong all along. In the distant past, a remarkable event took place: the creation of the universe. This appears to have happened from a single point in space. Scientists call this the Big Bang, and it is the widely accepted explanation for how our universe began. One of the reasons that astronomers came to this conclusion is because they observed that all of the galaxies in space are moving away from us. This led to the suggestion that everything might have once been compressed into an extremely hot, superdense point called a singularity. Another piece of evidence that backs up the Big Bang theory is the presence of cosmic microwave background, CMB, in the far reaches of space. This is the cooled radioactive remnants from the early universe, and it is so far away that it can only be seen by the most powerful telescopes. Scientists consider this fossil radiation and echo, or a shockwave, from the Big Bang. Although the Big Bang is the widely accepted explanation of how the universe came into creation, there are several theories as to what will happen going forward. One school of thought is called the Big Freeze. This theory suggests that the expansion of the universe will go on forever, leading to a distant future where everything becomes extremely cold and scattered. At the heart of this phenomenon lies dark energy, an enigmatic and unseen force that is estimated to make up a staggering 69% of the universe's mass. This mysterious energy appears to be propelling the expansion of the universe. The theory is that all of the heat and energy that was present when the Big Bang occurred will eventually spread out so far that the universe will reach an extremely cold temperature, known as absolute zero. This temperature drop could happen over the course of billions or trillions of years and could potentially render distant galaxies to be invisible from the Milky Way. But what if the universe doesn't keep expanding? What if it does the opposite? Welcome to the Big Crunch. This is a scenario where the universe doesn't keep expanding, but instead starts to shrink back together. For this to happen, the collective gravity of all matter in the universe would need to be powerful enough to challenge and overcome dark energy. During the Big Crunch, the universe contracts, leading to the merging of distant galaxy clusters. This process would cause stars and planets to clump together, resulting in a huge increase in heat and density throughout the universe. As the temperatures rise and the mass gets crushed into an increasingly smaller space, atoms would begin to break apart, turning the universe into the densest black hole. This could be the end of our universe as we know it. Yet, ironically, it could mark the beginning of a new one. There is a theory that the universe goes through cycles of expansion and contraction like this, and it has become known as the Big Bounce. According to this theory, there might have been countless universes before ours, and there could be countless more after our own. It is theorized that whenever the universe reforms, it could bring forth new laws of physics, giving rise to a whole host of different scenarios. For example, some universes could exist without any life, stars, or even atoms. If true, this would suggest that our universe is much older than we thought, having previously performed many cycles of contractions and expansions. Okay, now it is time to hold on because we are about to move on to some more unconventional theories. Next up, we will dip our feet into quantum mechanics and even ask ourselves if the universe even exists. Some scientists question that our understanding of the universe is flawed because we base our knowledge on what we observe and study in our local galactic neighborhood, and then assume that it applies universally. This concept is known as the Cosmological Principle. This is now being questioned because of the movement of our Milky Way galaxy. The thought is that the movement of our galaxy within the universe might be affecting our data. It may be that because our viewpoint is moving, it prevents us from seeing the bigger picture. If this is true, it could prompt us to question the reality of what we observe. However, at least we can be sure that our visible universe exists, can we not? Well, perhaps no, because there is more, and it involves quantum mechanics, a branch of physics where the classical laws of nature do not function anymore. One of the more unsettling discoveries in the past half-century is that the universe is not locally real. Real, in this case, means that objects have definite properties since the moment of their creation that are independent of observation. An example of this would be that a banana can be yellow even when no one is looking at it. Not real would mean that objects do not have definite properties until they are observed. Imagine that banana again. When no one is looking, it could have any color or no color at all. The theory is that the universe may not have definite properties until it is observed. But if that isn't unsettling enough, let's go a little deeper. Within the term locally real locality is the idea that things are only affected by their local environment. This idea suggests that you can't look into the night sky on Earth and flip a switch in another galaxy hundreds of light years away and instantly see the results. This is because conventional physics states that nothing, not even information, can travel faster than light. However, quantum mechanics disproves this by suggesting that two particles can be connected and affect one another, even if those particles are light years apart. This is known as quantum entanglement. This contradicts the principle of local realism and suggests that the universe that we observe may not have properties until we observe it. And, in addition to that, those properties could be susceptible to changing from particle signals hundreds of light years away. Mind-blowing stuff, indeed. If you liked this video, please consider leaving a like and subscribe. If you want more content like this, check out our other videos on the screen. Thank you for watching.